With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
So here in this question we have to find out the correct statement about the following equilibrium, right? So in this whole equilibrium you have been given as N2O4 that has been converted into your 2 times of NO2 and it has a positive delta H. So now let's start talking about the one by one. So here the first thing is the degree of dissociation with increase in this thing, right? So you have your N2O4 and your goes 2 times of NO2. Now here when you have initial concentration, let's say C, so after equilibrium it will be C into 1 minus alpha and this will be 2 times of alpha, right? So here if you are looking onto this, you have your delta H which is positive, right? So we can connect that and this with the help of your equilibrium constant. So here in terms of your K equilibrium, if we write so you have 2C alpha whole square divided by C into 1 minus alpha. Now onto this, if we are solving, so you get C and C cancel off, so you get 4 here and here you have C and we have alpha square and divided by again 1 minus alpha. Now here you have to understand the value of alpha is always less than 1, so that is always positive. Fine. So here if we are talking about the dissociation of N2O4 increases with the temperature increase. So now you have to first thing understand that whenever you have your delta H greater than 0, so that means this is an endothermic. So that means if I increase the temperature, right? So that will naturally mean that the value of K also increases or the K equilibrium also increases because it is becoming more and more favorable. So here if you are looking onto this, if K equilibrium if it is increasing, then we say that the value of alpha also increases. Why? Because it will more and more dissociate onto the right hand side. So alpha increases. So here we can say that this particular statement, whatever is given, is basically true. Now, second one, in this, basically you have the vapor density is what we have to talk about. So here we have to look onto the vapor density. So that will be equal to average molecular weight then divide by 2. So here if you simplify, so this would be equal to, now molecular average is total weight divided by total number of moles. So that is number of moles of N2O4 multiplied by molecular weight of N2O4 plus number of moles of NO2 multiplied by molecular mass of NO2. Then here you divided by 2 times of total number of moles, that is number of moles of N2O4 plus you have number of moles of NO2. Now here if you look on to, you have to substitute this particular value. Here you get the number of moles of this. So this is 2 sorry, here you get C times of 1 minus alpha, then you have 2 times of molecular weight of NO2 plus. Now here for number of moles of this, that is 2C alpha multiply by molar mass of NO2. Now here you divide this whole thing by 2 and then here you have C1 minus alpha plus here again you get 2C alpha, right? So this is if you now simplify. So here you will be getting C and C, everything will be cancelled off and here this and this basically cancel off completely. So you get 2 times of C, then you have molar mass of NO2. Then you divide by, you again have here C. So C if you take common and here you have twice. Then here you have 1 minus alpha plus 2, here you get 2 alpha. So 1 plus alpha. So here 2C and 2C will be cancelled So here you have molecular weight of NO2 divided by 1 plus alpha. Now here you have to understand that the relationship between that. So here you get vapor density is basically equal to molar weight of NO2, and then you have 1 plus alpha. So that means here you can say if alpha increases, then you can say vapor density decreases. And as we have established into the first equation, first statement, so if the degree of dissociation increases when temperature increases, so here also temperature increases, so that means vapor density will naturally decreases. So this is also correct. Moving on to the next one, when you are talking about the partial pressure, so partial pressure decreases when helium gas is added at constant pressure. So the thing is, we have to understand at constant pressure we are adding. So basically here in part C, you have at constant pressure. It's at constant pressure if you He gas is basically added. Then that what would that mean? That would mean that the volume of the total volume basically increases. If the total volume increases, then we naturally say that the concentration also will be changing. And if the volume increases and number of moles is same, so naturally the concentration will what? Uh, Decreases, right? So that means now we have to understand if the concentration decreases, the equilibrium will try to increase the concentration, right? So how do you increase the concentration? Now, and for this you have to understand this thing. So you have N2O4 going twice. So that means if you have to increase it, then it has to move on to the right hand side, right, to increase it. So here we would be saying that will imply that equilibrium shift right hand side. So that is RHS. Right now it is moving on. If it is moving to right hand side, then here we'll say that the pressure of NO2, partial pressure of that will increase, and partial pressure of N2O4 basically decreases. So here if you are looking onto here, partial pressure of NO2, it is saying it is decreasing. So that means here we can say that this would be your what? Your incorrect. So here this was your correct, right? Now moving on to your last part, so that is your part D. Here now you have at constant volume. So whenever you have at constant volume, that will imply no change of your concentration. So basically your concentration C does not changes. So if the concentration doesn't change, so that means here we can say it will have no effect on equilibrium, right? So equilibrium will not be affected with the change at constant volume, and that's why you will be saying that this particular option, whatever is given, is your incorrect. And here on to this particular question, we will say option A is correct, option B is correct. So this is we have to find out the correct ones. So I hope you have understood the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.